Today, we don't need to talk about batteries anymore. We've done this all over again. You guys know all about the batteries. This is going to be a battery-powered tool. So it's going to use the same things as before. This is, anybody know? I think John Brewer already said circular saw notes, right? So this, it's a giveaway. It is a circular saw. Okay, let's contrast for a minute. Well, I already showed you the jigsaw, and he's like, Heartline, we got a saw. There you go, jigsaw. You said it was all purpose. What do we need this for? Who could tell me? What's some contrast? What's some drawbacks?
Would it be that the circular saw is more adept at cutting straight lines?
Perfect. Thank you, Hannah and Michael Moon and Matt Fouts in the chat. Everybody's got it perfectly. Yes, this thing is steerable, right? This thing will follow wherever I drive it. I can turn this guy and make curves, right? It has that very narrow blade, so it's easy to steer. This is the one for curves, okay? The circular saw, because of its long circular blade, when you point it in one direction, it's going to continue in that straight direction. Just like Newton's laws of motion. Object in a straight line continues in a straight line. This saw is going to follow a path in a straight line. It does not want to turn. You can't steer this saw. You point it and then you go. That's the difference. That's why we need both of them. Now, the other thing I mentioned just a moment ago is this one has a straight blade. This one has a circular blade. That's where the name circular comes from. Pretty obvious, right? We can get that. Heartline has a circular blade. Okay. Remember from if you got to see the history of power tools video, if you were able to see that, or maybe you did some research on your own, you know that circular blade came about, the invention, because the hand saw only cuts in one direction. You look at those teeth, you can see they're pointed forward, right? So it cuts when I push it, but it does nothing when I'm drawing back for the next cut. So cut, dwell, cut, dwell. So I wanted to make that more efficient. They took the teeth and wrapped them around a circle. So now it's always cutting. There's no wasted motion, no inefficiency. That's where circular comes from. This circular saw is portable. We have other tools in this fabrication lab. Some of you have used them before. Panel saw, miter saw, table saw, those all use a circular blade, but they're different sizes. These aren't really interchangeable, okay? If I have a 7 1/4 inch circular saw blade, that goes with a 7 1/4 inch circular saw. I can't put it in it. This is a 6 1/2 inch. This only takes a 6 1/2 inch diameter blade. Not really interchangeable, okay? Here is a 7 1/4, here's a 10 inch. The 10 inch one goes in the table saw. The miter saws are 12 inch circular saw blade. So we can't really mix those up. The other thing about circular saws, generally, in here at least anyway, they're not going to be used for metal. We do have one metal cutting circular saw, but I want you to know this one we're not going to cut metal with. Only the limitation here is wood with this one. Okay. Let's go over some of the features real quickly. So we know this is good at cutting straight lines. Battery we already mentioned. It has a handle just like the other power tools. It has a trigger like the other power tools we talked about, but there's a difference. Okay? If you're writing things down, you probably wrote something down that was called variable speed. What did that mean? On the other tools, they were variable speed. Anybody?
You can change the speed of the tool?
Yes. And you do that by depressing the trigger, right? I press a little bit, it goes slow. I press a little bit more, it goes faster. I squeeze it all the way, it goes as fast as it can go. Just like your automobile or truck, I press on the gas pedal, it goes faster or slower depending on how much I press it. The circular saw is different, okay? The circular saw only has one speed. Slide the battery in there. I'm going to hold it away at a safe distance. I want you to listen. One speed. It's either on or off. Okay, that's the difference here. That's the difference with the circular saw. Next up, it has a shoe. Just like the jigsaw. Got the battery out for safety. Just like the jigsaw, there's a shoe. That's the base. You want the base, the shoe, resting on your material, not tilted up or down or side to side. Nice and flat and firmly placed. Okay. It has a bevel adjustment. Remember, I could tilt the shoe to make an angled cut. I loosen this knob on the front, and I can rotate that shoe. So here's the blade, and here's the shoe. And if I was actually cutting, I'd rotate this so that the shoe was nice and flat. Now you can see my blade is angled. Okay, probably won't need that much. Honestly, that bevel feature is for someone that maybe is a finished carpenter. So finished carpenter, if you guys know, they're responsible inside your home or office or residential, commercial. They're doing the trim pieces, like the pieces around the windows, around the door moldings, floor, baseboards, anywhere where there's going to be kind of an angled cut. That's a good place to bevel. So if you need to do that, you can do that. This saw also, some other new feature, I want you to write this down. This saw has a depth of cut feature. D-E-P-T-H, depth, like how deep something is, the depth of cut. Okay, so if I look at this saw, I can see, it's kind of hard to hold up in the air, I can see that there's some distance between the base, the shoe, and the tip of the blade down here. That distance right there, that linear distance, is the maximum thickness that I can cut through. It's 2 1/4 inches on this saw. That means if I want to cut through a 2x4, it's deep enough, right? This 2x4 is 1.5 inches thick. So I can cut through very easily with 2 1/4. Okay? So that's the maximum depth of cut. If I want to decrease the depth of cut, I'm going to orient you here. Here's the front of the saw, the side. I'm going to turn around to the back, rotate around to the back. See this little lever right here? When it's down, that shoe is locked. If I rotate this little lever upward, now I've loosened that knob and the shoe can move up and down in this orientation, okay? So if I look at that, what's happening is now with that maximum depth of cut, I can actually move that shoe and I can decrease how far the blade protrudes to almost nothing, right? There you can see that blade is just slightly protruding down below. So there's my depth of cut maximum, right? 2 1/4 inches, but I can decrease that. And then once I get it where I want to lock that blade back, or lock that lever back down. Now that's set, okay? So now I've got a fixed distance for the depth of cut. All right, great. Why is that important? Any ideas? Where might I use such a feature? Why not just leave it always the same and just cut through things?
I can cut straight grooves.
A groove, good, Logan Floyd. I can cut a groove, right? So if I cut a
If you're
groove,
cutting on something and the material that you're cutting is thin or small, you don't, like, you can avoid cutting your table.
yeah, great. Yeah, so as Logan said, I can cut a groove. So I'm just cutting a slot, but I don't want to go all the way through. I don't want to cut the board into 2 pieces. I just want a little slot in there for some reason. And Hannah's idea is a great one, right? I'm cutting on my tabletop, and I want to cut through my material, but I don't want to cut down into the tabletop, right? Similarly, and that's exactly what she's saying, is I want to cut through a layer, right? What if I had a couple boards and these were layered together, right? So I got this board on top of this board, and pretend for a minute, we like to pretend that these two are stuck together. They're glued together or screwed together. And I don't want to remove just this top layer. Okay? So I got this, and I really want this. I want this part over here, but I want to cut out some of that top layer. And just like Hannah's example, if this were the table, and I only wanted to cut through this layer, well, see that distance there, that 1/2 inch? If I set the depth of cut to 1/2 inch, then I'm only going to cut that deep. So now I can run my saw right down that line, right? Saw right through there at that depth, and I'm going to cut through this top layer, and I'll be left with this. Okay? So that depth of cut is very handy if you're trying to cut through just the top layer, or you're trying to avoid cutting into the substrate below, whether it's your table or whether it's the structure underneath. Maybe this is some kind of Maybe you got something going on like this, you know, and this is a structural member. This is holding all the weight, and this is just a decorative something. And you need to repair something. You can cut out the part that is just the decorative part, or the extra layer, this top layer, and leave below the part that you want to use for the strength. Okay, all good examples. That's a good reason to have depth of cut. Okay, let's talk for a minute about this little guard. Okay, so the Circo saw is a little bit more hazardous than the other saws, a little more danger, a spinning blade, a little more dangerous. So they wrap this guard around here around the top. I've covered up the top of the blade. And I've covered up most of the bottom of the blade. Again, my battery's out, I'm safe. I can see this little exposed part right here, but I've got this guard in the way. How does that come out of the way? Well, you can see there's a little handle here. I can manually move it out of the way. And I really only want to use this in case I want to inspect the blade or take a look at something or change the blade. But during normal operation, you do not need to worry about this. It will move out of the way on its own. Okay. Now, just for the demonstration, I'm going to flip this upside down. It's a little easier to show you. Okay. There's that guard. Okay. It's covering the bottom of the blade. In operation, in normal operation, my board is coming through. Okay. My board starts cutting through. I start cutting through my board, and you see how it's actually pushing that guard out of the way. So I'm pushing the guard. Let me turn this just a little bit for you. Hard to do this with one hand, guys. Okay. So the guard is pushing out of the way, pushing out of the way. See, as the board goes through, there goes the board. Pushing, 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 pushing. I'm cutting through, cutting through, cutting through, cutting through, and I get to the end and snap, comes right back up. Okay, so that spring-loaded feature allows it to pop back into place after you're done. So if you're sawing in normal operation, it's going to cut through there, it's going to push it out of the way, you're going to get through the end of your cut and it's going to snap back. So you don't need to pull that out of the way manually. You can just push it through and it'll work properly. Okay. One more thing I want to tell you about this. I think I overlooked this at the beginning. This one has one little extra safety feature. Remember I told you a little more hazard because you have a spinning blade? Well, up here where the trigger is, and again, remember this trigger is single speed, so it's not variable speed. I squeeze the trigger, it's on or off, but they added another little safety feature right here. This little button or lever. Okay. That is a trigger safety. I have to hold that trigger safety down before I can pull the regular trigger, okay? So if I just try to squeeze it, nothing happens, it won't move. I have to hold it down. I'm going to use my thumb on this side. Use my thumb, I'm going to push that down, and then I can squeeze it, okay? So the way it happens in right-handed operation, there's my trigger finger, this is my thumb. My thumb holds down the safety, and then my trigger can move. Okay, hold the safety down, squeeze the trigger. That's right-handed. The good thing is they thought about it and they said, hey, what about left-handies? Southpaw also works the same way. My thumb can still reach the other side. So either side. So just a trigger safety, you have to hold it down to make the saw work. Okay, we talked about bevel, we talked about the shoe, we talked about the depth of cut. This blade you will not have to change in here. We talked about jigsaw blades. They're toolless, remember? You just open that little lever up. The saw blade is released. I can put a new saw blade in, and I can close that back up. And I've got a blade change really quickly, right? It's more complicated. Yeah, Tino, good question, good comment. With this Circo saw blade, the blade change is not so easy, right? First of all, it's not toolless. You won't need to change this blade. This is a good blade. It's probably going to last a long time. There's no reason for a student to change it. If you think it's dull or damaged, please let Mr. Claney or I know. but I'm going to show you this just because you guys like to know things. This one requires a tool. That little tool is kept right here. It's just held in by friction. So if I pop it out, you'll see it's just a little Allen key hex wrench. Okay, so I do need a tool to change this blade, and I need a couple other things because the blade is held in here by this screw. This tool fits in that screw, but if I put that in there and start turning, the whole thing turns. So I need a way to stop the blade from turning. There's a little button right here on the top, this little black button right there. Okay, I have to, yeah, blade. Well, you don't want to use it as a brake. It's actually gonna reach in there. It's gonna find a notch in the shaft, and it's gonna lock. So it's gonna lock in there, and then once I've got that blade locked, then I can turn the wrench, take the screw out, take the old blade out, put the new blade in, screw the screw back in, push the blade lock, turn the wrench, tighten it up, let go of the blade lock, put the wrench back in its little holding place there. You can see a lot more difficult, a lot more steps. So don't worry about changing the blade. We'll help you if it's needed, but there's no reason to. It doesn't have the versatility of the jigsaw. It's probably only going to keep this. The jigsaw is easy to change. We're going to change it for versatility, for different materials. Circular saw, not so necessary. Okay. What do we got? About 19 minutes left. All right, keep on moving. I did mention that's a 6.5-inch saw, I think. And I want to mention this, we don't use this much in the fabrication lab. However, I did want to show it to you. Somebody has a general purpose circular saw at home. It's probably this style. This is a little bit bigger blade. It's a 7 1/4. This was the standard for a very, very long time, still is, for portable corded saws. If you go buy a saw with a cord on it, it's a portable saw like this, probably going to be 7 1/4. Just gives you a bigger blade diameter. Lots of the features are the same. Still has a method for raising and lowering the shoe to change the depth of cut. Still has a method for making a bevel, so I can turn the shoe and get a beveled cut. Still has that little spring-loaded guard. Lots of the features are going to be the same. Trigger operated. Okay. So just showing you this. We won't use this much in the fabrication lab. We have this one here because we outfitted it with a special blade for cutting plastic, and we just leave it in there. We don't even change it. So if we have to cut plastic, we'll go grab that one. This one we're going to use primarily for wood. No need to change the blade. Okay, any questions on any of that so far? So far. Okay, if you're taking notes, the things I think that are important so far are that the circular saw is best for cutting straight lines. Does not cut curves. Okay. Also, it is a single speed, not variable speed. And you have the depth of cut adjustment is very good for cutting slots or cutting layers. Can do bevels with that beveled adjustment if you want to. And don't forget, it is the same battery suite as the others. So that battery program works in all of these tools. I'm not trying to be a salesman. I just think it is wonderful that we don't have 17 different batteries on here. If anybody has that situation, you'll know what a pain in the neck it is. If you have different batteries for different tools, it is nice that you have one single one. It's like the corded tool, right? Could you imagine if everything that you had a different cord, a different plug? It's like the phone. Whenever you get a different phone, they always change the plug. I don't know. I think iPhone started standardizing. But for a long time, some of the others, the Androids and that, you bought a new phone and it came with a different plug. You're like, I already got 3 chargers, one for the car, one for my nightstand, one for a travel bag. Now I got to throw them all away and get a new charger, right? So you can imagine if
a MacBook have like multiple different chargers every time they update one.
That's a good question. Probably Huey could answer that. He knows I am not a Mac guy. But it's possible, and hopefully they're working on that because that would really solve a lot of things. Because if you think about it, This little 120 volt, 110 volt plug is pretty universal, right? So it's nice. I don't want to get off track on phones, guys, but it's nice to have the same battery. Just trust me on that one, okay? It's nice to have the same battery for everything. All right, guys, sorry I didn't mean to start the, I did not mean to start the computer war, the Mac Android war. Let's agree to disagree. No, back on track, back on track. Okay, no more comments. All right, so hey, let's change gears here, talk about blades a little bit, because the circular saw blade, I got to show you some more features. Now listen, this is important. I got a bunch of blades here. I want to talk about blades. I want to tell you blades are different for every single size. We started mentioning this last time about the jigsaw blade. You guys drew the big You guys drew the jigsaw blade yesterday. You know that the tooth profile can be different and the shape can be different, the rake, the gullet, all those things are important, right? I want you to know, maybe someday one of you will be a blade engineer and you'll start thinking about all the different teeth, okay? But for now, it's probably boring. You're saying, Heartline, why are you telling all this? What I want you to get from this, guys and girls, is that it really matters what blade you choose for what job. For safety, so you don't get hurt. For the most efficient cut, so you're doing the fastest and best job that you can. And for protection of the tool itself. So you don't get hurt, but you don't hurt your tool either. We don't want to damage the blade. We don't want to wear the blade out too soon. And we want to be as efficient and as productive as we can be. So just bear with me. I'm going to show you some more things about saw blades. You're going to have a plenty good education on saw blades. Again, the purpose is not to make you a professional saw blade, but to let you know there are many different kinds, and so you can see some of those different kinds. All right, the first thing I want to tell you about, though, and I'm going to show you first, then I'm going to show you on a slide. I'm using this as an example. It's a handsaw. I keep showing you this because there are some things about teeth that are easier to show with this. But I want you to look at this saw blade and you say, okay, there's the thickness of the saw blade. We talked about kerf last time, K-E-R-F. Does anybody remember what kerf is? K-E-R-F. John Brewer.
It's like the width of the blade and the size of the cut it leaves horizontally. Yeah, the slot left by the blade, like Ben said.
Very good, both of you. You guys are perfect. It's the slot that's left by the blade. Now, I might have said that it's the thickness of the blade, but I want to recant that, okay? If I told you last time it's the width of the blade, it's not. It's the width that's left by the blade, and here's why. If this blade, if I were to measure this with a dial caliper, you guys remember that last year, you put that thing on there, and it's a little dial, you read it, it might say 0.055, right? And say, well, that's the width, that'll be the width of the slot. My kerf will be the same thickness as this. Well, there's a trick here, guys. I want to show you something. Have you ever looked up close at saw teeth? Does anybody notice anything about this saw teeth? Yes, it's the width of the groove left by the blade, not necessarily the thickness of the blade. Yeah, they're bent, right? So one tooth goes like this, and the next tooth goes like that. They stick out a little bit, right? Very good. You guys are all on it, right? They're uneven. One's this way, then this way. Then they're alternating. Tooth, 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 tooth. Okay? All right. Why, Heartline? Why? Tooth set. So if you look at that little picture up in the upper left-hand corner, that light blue colored block is the material you're cutting through. And the brownish colored device there in the middle, that's the saw blade looking from the edge, looking from along the saw blade. So there's those teeth going one tooth to the right and one tooth to the left. So can you see now that because they're staggered, so tooth set, you can write that down, tooth set, S-E-T, is the staggered arrangement of the saw teeth. Okay, and it's to provide clearance for the saw blade body as it travels through a workpiece. So I need some extra clearance in there. I need some room for the saw blade to travel through. So by making those saw teeth bent a little bit to the right or left, I make the kerf a little bit wider, and now I have clearance. When the saw blade gets down into the material, there's some room for it to move, right? So that last statement is one of the best there. It says to make the kerf wider than the blade so that the blade moves through the cut freely without binding or excessive frictional resistance, thus reducing the heat generated. Okay, come back live for a second. Remember my saw example? You know, it has set on it. Look here, you see all this? What's going on here? It used to say crosscut or something. You see how everything's smeared? If you think about that, it really does. When you start a cut and you're just touching the teeth, you're good, right? What happens when you get down this far, right? I'm all the way down into the material now. The wood is rubbing, the wood or the material, whatever, it's going to rub against the side and produce friction. So if my teeth, the set allows me to make that groove just a little bit wider, then when I get up farther up here, I've got a little bit of wiggle room, right? I've got a little bit of clearance. It still rubs a little bit, but could you imagine if I didn't have any clearance in there at all? This would always be in contact, and I'd get a lot more friction, okay? All right, I'm watching the clock, and I know we gotta keep going. All right, we're getting close, guys. Let's go back to the slideshow. There's just a little bit more there, and we'll be done. Okay, can we see the slideshow again?
Yeah.
Okay, good, thank you. So going on a little bit more here, here's a set of the side. So this is looking down on the edge, the way that I showed you the saw blade when I stuck it up to the camera there. There is more than one way to do this. You don't have to just alternate every other tooth left and right. You can alternate, as it shows up there in the top, the raker, and then skip one. So I can go left, right, skip, left, right, skip. I could do the alternate in the middle there, which is kind of left, right, skip. I can do wavy in the middle toward the lower left, right? I can start out, I can make one tooth set a little bit to the left, the next one a little bit more to the left, the third one leaving a little bit more to the left, and then I can start decreasing that set back to neutral, back to the center, and then I can go the other direction. A little bit to the right, a little bit more to the right, a little bit more to the right, then back toward the center, gradually back and forth, all right? And then trapezoid, which requires a special shape of a tooth. Point of this is, again, guys, I want you to realize lots of different ways to make a saw blade and lots of different ways to make a saw blade better for one material or better for one type of tool or better for one finish, okay? Now the little picture on the right is for carbide teeth. We're going to come back to that, so you can ignore that for a moment. And take a look here. Here are a couple of saw blades, circular saw blades. On the left, the kind of rusty looking plain Jane saw blade. That's what we started out with. And all it was just a piece of metal stamped out. We cut out the shape of the teeth, and then we gave a little bit of set to each tooth. And away we went, right? And you could sharpen it if it got dull, but it was pretty basic. It's made out of high-speed steel, which is just steel that has some alloy to it. You guys know, probably from chemistry, if alloy is a mixture, so we add things to the metal to give it different properties. In the case of a saw blade, one property that is important is wear resistance. So we want to make sure that blade wears a long time. We don't want the edge to become dull. A sharp edge is important for a saw blade, and if it doesn't have wear resistant, it would quickly dull and would become useless. Okay, so the one on the left is kind of where we started. You can still buy high-speed steel blades. They're not as popular, but they're still economical, and for light usage, they work pretty well. But if you want to step up and you want to go, hey, I want a blade that lasts a super long time and gives super good finish, and take advantage of all the modern technology that we have, then you want to go over to the right-hand side, and you want to say, give me a carbide tip saw blade. So carbide, we're going to get into our chemistry class, And we're going to remember that we're going to notice that carbide is a compound. I'm going to take carbon and I'm going to mix a metal with a carbon, and I'm going to get a new compound. And I usually mix things to make better properties. So the carbide is going to be a harder material it's got the right properties for cutting tools. It has way better wear resistance. So the high-speed steel was pretty good. The carbide is even better. It stays sharper longer. So if you see down in the bottom down there, I can mix a couple different metals and get these carbides compounds. Tungsten plus carbon is tungsten carbide. I can mix titanium, tantalum. All of these are different combinations that give me that metal and carbon mixture for a carbide compound. Now, what do I do when I get that carbide compound? It's good wear resistance. Well, I'm going to make it into a little tiny chip. And then I'm going to attach that little chip to the tooth. If you look closely at that blue saw blade on the right, you see the main body is blue. But if you look right on the edge of the saw tooth, any one of those little individual teeth, you're going to see it kind of looks like it's a little bit shiny. It's actually a different material. So I make a little chip out of carbide, and then I glue it or cement it. I cement it onto each tooth. So now I have a carbide tipped saw blade. Carbide tipped saw blade. Okay? So let's exit that. Carbide tip saw blade. Wonderful invention. Carbide tip saw blade. Okay. Thanks, Brewer, for those photographs again. That's very helpful for your classmates, and I appreciate it. So carbide tip, and great. That Brewer, look at Brewer's top picture there. The 3 saw blades, and you can see because I made that little carbide tip, I can change the shape of that. Right? I got the triple chip. Sometimes they call it triple grind. I got the flat top. I got the alternate top bevel. So those 3 that he's showing there in that picture are just ways that I can change the profile of the tooth by changing that little carbide chip. Okay, I know where you're going, right? You're going, Heartline, it's about time to go. Tell us one more important thing, and I will tell you this. Why don't we just make the whole saw blade out of carbide? It's okay, I'll wait. You guys go ahead and think about it.
It's
Would
expensive.
it be fragile and expensive?
Haha, very good, guys. It is expensive. That's one thing. It's expensive. But also a few people said not strong enough, it's fragile. It's brittle. It's very brittle. So it stays sharp. It's got great wear resistance. It's cutting and cutting and cutting, and it takes a long time to wear that edge away. So it stays sharp a long time. But you cannot smack it. Okay? No, it has virtually no impact resistance. So as long as you're making a nice smooth cut, it will last a long time. But if you slam that thing into your material or you drop that blade, it's going to be ruined because the carbide is very brittle. It'll break. Here is a blade that I brought in, and I want to show you. We're almost done, guys. Right there is a good tooth. Okay? So you can see. You probably can see now that little carbide tooth on there glued to the blade. So this is the metal blade backing part. There's that little carbide tooth. Look at what happened here. Ruh-roh. See that one? See how it got dinged? So this is a 60 tooth blade. Something happened accidentally, I'm sure. It got pulled in the material too quickly, or it got set down improperly, or something chipped that tooth. So now a 60 tooth blade, I really only have 59 teeth. This is not junk. I'll keep this. We'll probably keep using this. But you can see over time, if I would ding up a bunch of those chips, it'd be ruined. And there's no way to even sharpen it. It's too much gone. So in closing, carbide tip blades are wonderful, right? They're very popular for circular saw blades. I got this one. I got this one. I got this one, all carbide tip circular saw blades. On our saws in here, the table saws carbide tip, the miter saws carbide tipped. This circular saw is carbide tipped. We love them, but we have to take care of them. Don't ding them up, and they'll last a long time. Nothing wrong with the old high-speed steel, but the carbide tipped is wonderful. Any questions on anything? Is it easily bendable? No, it's not. It's not easily bendable. Oh, I see. Hannah was answering the other question. Sorry, I'm just scrolling through, guys, see if I missed anything. Chat, more friction. Yeah, you guys are doing good. You guys had good answers in the chat there. Any questions on any of that? What's coming up next, you ask? Okay, so tomorrow we'll have another little exercise. Like yesterday, we'll just explore deeper. No new material. You'll be kind of independent on your own. And then I don't know if it's going to happen Friday. It's going to happen pretty soon. We're going to have a kind of a comprehensive quiz over all of these things that we've been taking notes of. You guys are probably aware that it's, at the end of the quarter is right here. Friday, Monday, sort of the end of the quarter, we're going to close off the grade. So Mr. Cleaning and I are trying to decide. I think we're probably going to postpone, but we'll see. We'll give you plenty of review, so don't worry. It's not going to be a pop quiz and surprise you. We'll review, but we will at some point kind of have a test over all these different things we've been talking about. Anyway, turn in your notes from today like you've been doing. Put them in Canvas, and I will see you tomorrow. Make sure you sign off and wave out. Bye. If you have any questions, stick